All right, this lesson we're going to talk about the Pythagorean identity, which is sine squared plus cosine squared equals 1. Now, if you recall, sine is equivalent to the y coordinate. So you could rewrite this as y squared. Cosine is equivalent to the x coordinate in the unit circle. So another way to write this identity is y squared plus x squared equals 1. Now, if we look at just a regular old right triangle, reference triangle in the unit circle, that 1 is coming from the fact that the radius of the unit circle is always 1. This down here is your x coordinate, and this right here is your y coordinate. So right triangle, think about what other familiar formula uses this pattern of something squared plus something squared equals the hypotenuse. And technically you could write this as 1 squared, but 1 squared is just 1. This is the Pythagorean theorem, is really what it is. And that's why it's called a Pythagorean identity. We're going to use that here to help us solve some of these trig problems. But let's do an introduction problem. Let's say this particular case is a 45-degree angle. Let's do an easy one. So 45 degrees, we know the x and the y coordinate at 45 degrees are going to be the same. And in this case, they're both radical 2 over 2, and even better, they're both positive. So in this particular case, the y coordinate, and doesn't matter which way you write this, you can reverse the x and the y. In this particular case, let's actually write this out. So we write this out as the sine squared of 45 degrees. The squared is kind of in a tricky place for some people. It's actually before the angle measure, because you're not squaring the 45 degrees. You're squaring whatever the sine ratio and the cosine ratio of 45 degrees is. So again, we know this is y squared, and we know this is x squared. I just want to write this out formally. So the y coordinate at 45 degrees is radical 2 over 2. And we're going to square all of that. The x coordinate at 45 degrees is also radical 2 over 2. So then let's simplify this and show this is true. If you square everything on the inside, if you square a square root, those just cancel out. And if you square this bottom number, you get 4. So you get 2/4 when you square radical 2 over 2, which means you're going to get the same thing when you square this other radical 2 over 2. And of course, 2/4 plus 2/4 is 1/2 plus 1/2, which equals 1. So that's the Pythagorean identity, identical to the Pythagorean theorem. So let's use that fact to help us solve a couple of problems. So example 1a, we're going to figure out what the exact value of cosine of theta is. So in other words, we need to find the x value. We don't know what the angle is, so that's why we can't jump straight to the unit circle. We are going to use that when we answer part B. So we're going to use this Pythagorean identity, and I'm going to abbreviate it here, sine squared plus cosine squared equals 1. Now, we already know what the sine value is. The sine value in this case is negative 1/2. That's before we square it. The cosine value is, of course, our x coordinate. So this ends up being the equation we're solving x for. Now, keep in mind, it's an x squared, so technically there are 2 answers. If you think back to the quadratics unit, there's going to be 2 answers. But since we're in quadrant number 3, is x going to be negative or positive in this quadrant? If you said negative, you're right. In quadrant number 3, x and y are both negative. So keep that in mind as we go through this process. Negative 1/2 squared is positive 1/4. We're going to subtract 1/4 from both sides, and that gives us x squared equals 3/4. And we take the square root of both sides. Typically, we get a positive and negative answer. In this case, we only want the negative answer since we're in quadrant number 3. So we're going to take the square root of 3/4 And then we can simplify this just a little bit. We can rewrite it as negative radical 3 over 2, since the square root of 4 is 2. So that's our x-coordinate when we're in quadrant number 3 and the sine value is negative 1/2. And really, even though we don't know the angle measure, that's probably something you still could use unit circle to find out, because if the x-coordinate is a negative 1/2, the y-coordinate is going to be the radical 3 over 2 option. So now we can look at the unit circle. We want to determine what theta is. So we're going to do that by looking at the unit circle, and we need to find the angle that has an x-coordinate at negative radical 3 over 2 and a y-coordinate at negative 1/2 in the third quadrant. So 210 degrees should be that angle in which you get an x-coordinate of negative radical 3 over 2 and a y-coordinate of negative 1/2. Try your turn number 2 now. All right, so here's the work on your turn number 2. Again, they don't ask for what theta is in this problem, but we could easily find it. And keep in mind, again, some of these are a little easier because they are exact values on the unit circle. At some point, you may get a fraction that is not on the unit circle, so you need to make sure you show your work for these problems. The process is still the same, but you're not necessarily going to get a familiar fraction like we did here. All right, the final one we'll do together is we're going to confirm the Pythagorean identity is true for 7 pi over 4. So this is very similar to our introductory example where we did it for 45 degrees. So in other words, in this problem, let's write out, and again, it doesn't matter if you write sine squared out first or cosine squared. But let's write it out, what we're trying to prove. Oh, I put the square in the wrong place. Remember, we're squaring the trig function, not the value that we're plugging in. You can use the unit circle here if you need to, but we're basically trying to prove this. So 7 pi over 4, find that on your unit circle. That's equivalent to 1 1/4 pi, so it's a 45-degree reference angle, but it also means we're in quadrant number 3, where both x and y are negative. And in this case, they're both negative radical 2 over 2. So the sine of 7 pi over 4 is negative radical 2 over 2, and so is the cosine. Must show your work in this problem because all we're doing is confirming. We're not really solving. When you square a negative, it becomes a positive. When you square a square root, they cancel each other out. So you get 2/4, and you're going to get 2/4. Remember, you got to square the bottom number as well. Just like the introductory example, 1/2 plus 1/2 equals 1. You confirmed it. Pause the video. Try that last one on your own. So this should be the setup. The sine of 330 is negative. When you square negative 1/2, you're going to get positive 1/4. When you square radical 3, you get 3. When you square the 2 at the bottom, you get 4. You get 3/4 plus 1/4. 3/4 plus 1/4 is 1. So we've confirmed it.